This meeting is being recorded.
Okay, can someone summarize yesterday's class, guys?
సౌండ్ నేను పెట్టాలి, నేను సౌండ్ పెడతా. సౌండ్ నేను పెడతా తగ్గి నాకు పెట్టుకున్నావా?
Anyone can summarize yesterday's class, please?
So we discussed configuring devices using local passwords yesterday, and we also discussed setting privilege levels, where Cisco's privilege levels are defined from 15 to 0, where 15 is the super user full access privilege, while 0 is the lowest access level. We also discussed that service encryption for passwords, where only users that possess the password will be able to decrypt the passwords and be able to view them as well. We also discussed banners. We discussed Active Directory, where it is a server and the user's username and password will be synced to the AD, and it also follows the AAA pattern, where it is authentication, authorization, and accounting. We also discussed network access control, and finally we discussed remote access and site-to-site VPNs.
Okay, thank you, Shiva. Yeah, that was a good summary. Yeah, we discussed about starting from configuring local passwords all the way to site-to-site VPNs. We thought the local passwords are not secure, so that's why we went to Active Directory, and we thought having just AD is also not secure. That's why we went to multi-factor authentication. We discussed about what people have, what people are, or what people know. Like knowing is something, they know their password. What they have is like they have a phone with the OTP, they can send that, right? On something like who the people is, like for example, maybe their finger scan or their retina scan or facial recognition, like that. So biometrics, right? We did added multi-factor authentication, and we discussed about various roles, for example, like privilege levels, that like we discussed for Cisco, like having a super admin role versus having a read-only access. And we also discussed about .1x, right? In the .1x means like we are doing network access control, where we have a supplicant authenticator or authentication server. We discussed about the workflow there. And also we discussed about how we can configure the local passwords on the box, how we can make secure, like creating a banner and all. So yeah, that's pretty good summary, Shiva. Thank you. But at the end, we talked about a remote SSL VPN having a user sitting in a remote space and connecting to the office versus having two offices connect each other with a site-to-site VPN tunnel. I think we stopped where we stopped configuring them, right? I think that's where we stopped. So today, let's see the configuration part at the CCNA level. Let's not go to the NP level, like creating and debugging the site-to-site. I think it is on the security end. The network end does not have the VPN, but still, as an engineer, you should know how to configure a VPN tunnel. So let's talk about that. Any questions before we start today's class?
No, sir.
Okay. So we're going to talk about site to site. VPN tunnel config. Come on. Okay, so let's take site A, site B. So inside the site A, let's say there is an edge router. Site B, there is an edge router. So router or the firewall is where we turn on the VPN tunnel. So there should be a tunnel. For example, let's say there are two users here. User 1, user 2, user 3, and there is a user 1, user 2, user 3. So now this user should be able to go through this router, and there should be a tunnel formed between these two, and the traffic should flow over the tunnel, reach here, and then they should be able to talk to this user. So even though these, let's say this is connected in Austin, Texas. Let's say this is in Atlanta. Okay, so we wanted, even though there is internet connection, there is internet connection for this site and there is internet connection for this site, like Verizon or AT&T, right? They have internet connection. So we wanted to securely connect this router with this router. So to do this, there are two phases. Phase 1 is phase 2. Phase 1 is called ISA-KMP. Phase 2 is called IPsec. Okay, in phase 1, we will form the reachability to the neighbor, meaning we will try to associate with the neighbor, meaning this router will try to associate with this neighbor in the phase 1, meaning it tries to form the neighborship or reachability. After forming the neighborship, in the phase 2, the traffic of the users will actually flow over the tunnel. So phase 1 is for the connectivity between the routers, and phase 2 is for the actual data traffic or the user traffic to flow over the tunnel. So that is what it is. In the phase 1, it is called ISA-KMP. The full form is Internet Security Association and Key Management Protocol. This is a full form. IPsec is IP security. You know already what is IP, Internet Protocol. So Internet Protocol security. Don't have to write down. Okay. So again, I'll repeat, for phase 1, the phase 1 is used to negotiate with the neighbor and form the neighborship between both the routers, and phase 2 is for the actual user traffic to flow over the tunnel. So to form the neighborship between this and these guys, they should have a base reachability. When I mean reachability, they should be able to reach this on UDP port 500. UDP port 500. The port is just the reserved port for this traffic. It's a protocol with UDP. You guys already know UDP is like connectionless protocol. So it does not work with the acknowledgements. So here to connect with something on the internet, we use UDP. If there is no response back, it will send a request again, right? It does not have to get the response back like an acknowledgement back. So ISA-KMP works on UDP port 500. And next thing is to have the parameters match. So both routers will exchange the parameters like IP addresses. So router A on the left-hand side will talk with router B. They exchange their IP addresses. And they exchange their AES, that's to encryption algorithm. They exchange their pre-shared key, which is the password. They exchange their authentication parameters. We can say authentication header. They exchange their DH group, which is called Diffie-Hellman group. Diffie-Hellman group. So what is this Diffie-Hellman group? To protect the password, that we are sending, the DH group will put the password in an algorithm and make it secure. So the DH group is like an algorithm that is used to protect the password. So all these parameters have to match on both sides. For example, if there is a third site, if they want to form the neighborship with my site, unless these parameters match on the port 500, they cannot form the tunnel. So to have the security in play, all these parameters have to match in the phase 1 to form the initial phase 1. After forming the phase 1, again in the phase 2, this neighbor IP need to be allowed over the tunnel, meaning that they call it as interesting traffic. Okay, let's phase 2 is where actual data traffic will flow, which is called interesting traffic. Okay, for that, the interesting traffic should be done with an encryption domain, which is called ACL. Like we have to permit or deny the traffic. So on the router, I can do permitting the user to allow that over the tunnel or not. Whether I want to allow the traffic or whether I should deny the traffic. That can be done with an ACL. You already know ACL is nothing but access control list. Meaning it's like a gatekeeper. It will check the user IP. It will make sure whether to allow the traffic or deny the traffic. ACL is just like an firewall, or it's like an gatekeeper, which is either permitting the traffic or denying the traffic. So that will be done on the phase 2. And also the phase 2 will have something called transform set. The transform set also will have the algorithms. Just like phase 1, it has encryption algorithm and authentication header. They both will be using in the phase 2 as well, because even inside the tunnel, if someone captures the data in the tunnel, it has to be end-to-end encrypted. So that's why we again do the transform set in the phase 2. Which will have the
Sir, I have a question. Sorry.
Go ahead.
So the DH group, does it happen in phase 1 or does DH group happen in phase 2 also? Because we're just grouping them, right?
So let's talk about the DH group a little bit. 1 second. So how do I do this? Let me complete this. I'll come back because I want to clear this and explain that again. Okay. So your question is whether I use the DH group in phase 1 or phase 2. Okay. I'll keep the question aside. Let me complete the transform set. The transform set will be pointing the encryption algorithm and also the authentication header in the phase 2 traffic as well, for the user traffic as well. So these are the parameters that will be discussed in the phase 2. So in the phase 2, they will send the actual data. They will be controlled by the encryption domain, which is the ACL, and it has the transform set. Okay. And phase 2 will have a crypto map. Crypto map is nothing but combining phase 1 and phase 2. You will combine these phase 1 parameters and phase 2 parameters, and you will apply that to a crypto map, and you will apply that crypto map to the router interface. So combining all these parameters into a crypto map, and we apply that crypto map to the interface of the router. Just like policy map we did for the quality of service, this is called crypto map. The crypto map will have all these conditions defined, and we will apply that to the router interface. Okay. So now let's talk about the question that you asked. Let me clear. Before I clear all of this, do you have any questions on this, on what you're seeing on the screen?
if possible, can this concept be explained again?
At what part?
So after, I mean, from the process parameters from IP address exchange, I've lost it.
Okay, so for phase one, let's do one thing. Hold on. Okay, phase one is nothing but, let's say there is a site A and let there is a site B. Phase one is nothing but having a, let's say having a road. Okay, so let's say this is location A, location B, and you are having a road to have the connectivity between the sites. That is phase one. Phase two is nothing but sending the traffic over the road, meaning actual car going on the road. That is phase two. Okay, phase one is nothing but having a road between two sites. Phase two is nothing but sending the cars over the road. That is phase two. So in the networking concept, phase one is nothing but having a tunnel, which is nothing but your road. Phase two is nothing but sending the actual data traffic, the user traffic over the tunnel. Okay, is that clear on that part?
Yes, yes.
Okay, now relating that to the phase one, the phase one will have some parameters to match to form this road. Okay, otherwise the road will not connect two sides. The tunnel will not connect. So there has to be some parameters matching on both these sides. Okay, and what are those parameters? The IP address exchange, encryption algorithm, pre-shared key, authentication header, and DH group. You already know what is IP address. This site IP address will talk to this site IP address on this port UDP 500, and they both have to talk between them with the IP address. So that is IP address exchange. You already know encryption. Encryption means that these two have to match on a specific encryption. For example, if you say cheat code A or ABC, the cheat code has to match on this router. So when, let's say you own a company called X and you wanted to have a remote site and that site is called Y. So you being a network engineer, you have to configure the same encryption algorithm of site X and site Y to make sure that you can form the tunnel between these two sites. If the encryption is not matching, that means your site ID is not matching. That means that this site is no longer belong to you. Someone else configured that and you don't want to form the tunnel. To protect that, we create the encryption algorithm. The password you guys already know. You'll put a password to make it secure, right? So you put a password here and that password has to match. For example, if you put password like I love CCNA here, that I love CCNA should match it here. Otherwise, the tunnel will not form. An authentication header. What is authentication header, guys? So let's talk about authentication header a little bit. I don't want to clear all of this, but let's say. Before forming the tunnel, I'm going to send a message which is encrypted. Okay, the message is encrypted. Okay, which is non-human readable format. Okay, that is all encrypted. Okay, you put all of this message into an authentication header, meaning you will put all of that into a header value, which you will mark it as, let's say, this is the authentication header for this total encrypted message. Okay, if this line message, if that is not matching on this router, I cannot see what's inside the message. So to protect the data, we put one more header on top of that to match it. Think about like this. There is a person, and this person has a briefcase with him. Okay. And there's another person, he is also having a briefcase with him. Okay. So they both want to exchange their briefcases. Okay. And these briefcases have a key to it. Okay. To give this briefcase and key to this person, the keyword is called red. Okay. When this person come and say the keyword red, this one will know that, okay, he is the right person to talk to. Then they both exchange their keys and the briefcases. Similarly, here the authentication header is the red, and the encryption is the key, the key in the key, and the actual data is in the briefcase. Is it clear?
Yes, yes, sir. Thank you.
Okay, now let's talk about the DH group. DH group is so which example I can give for DH group? Let me think about this. Let's say, I don't know how many you guys went to casino. So I think that's not the right example. What else I can talk? Okay, let's talk about this. Do you guys know multiplexing? What is multiplexing? Anyone know what is multiplexing? Okay, ignore that. That's fine. Let's talk in a general example. Let's say there is a machine. Okay. Let's say you put in a dollar note into the machine. Okay. So once you insert a dollar note into the machine, okay, vending machine. That's good. So let's say this is a vending machine. Okay. Let's say there is a Coke, there is Sprite, all those snacks in it, right? Okay. Okay. And then you get the product out of it, out of vending machine. So, but you have to enter a code to it, right? So I think, for example, let's say this is B1, this is A1, this is C1, right? So the dollar note, you enter the dollar note, and what you have to do, you have to press that B1 number, you will get the snack out of it. So in the same concept, the DH group is the algorithm. Okay, you put the DH group algorithm to it, and you are sending your data. The data is nothing but the snack. So when you put your dollar note, if you enter the right combination, the right output will come. Okay. This is the same concept works with the DH group. In your tunnel, when there are two routers, if they both negotiate with the right DH group, they both are entering the right code to get the same right output on both sides. If this DH group is not matching, if this dollar note is not matching with the right combination, they're not getting the right product out. So for that, they both have to enter the right algorithm to get out. I think this is the closest example I can go. Is it clear?
Yes, sir. Got it. Thank you.
Yeah, similarly, in your phase 1 and phase 2, they both, you use the DH group and they both has to enter the right combination with the right input data, so they get the right output. If you guys know multiplexing, what is multiplexing? There is an AND operation or OR operation. So when you enter your data, it goes through an algorithm, multiplexing algorithm, it sends you the output out. That's why I asked you guys if you guys know multiplexing. Multiplexing is nothing but sending multiple signals. It goes to an algorithm and it goes with an output. That is called multiplexing. You send multiple signals, you get one output using AND or OR operation. I think this is a concept in electronic subjects. So that's the same concept here. So this is DH is nothing but an algorithm that works inside by taking multiple traffic and it sends an output out. Just like you put a dollar note, you select the right combination, it gets an output. That same concept works in the DH group, and that has to match on both sides. I think we went way above the CCNA. This is not part of syllabus. CCNA just tells you to connect between the two sides only. I think there is no explanation about all these parameters and the configurations as well. Just understand the site-to-site VPN tunnel is connecting two sides. The parameters have to match for the phase 1, and phase 2 is where actual interesting traffic will flow. But if you guys are interested, yeah, you can always dig deeper. Curiosity is right. If you have curiosity, you can always learn more. I think that's all on this topic. Any more questions?
Sir, I had another question. Okay,
Okay,
you can go ahead.
okay.
Yeah, Ravi, so these 5 like parameters will be checked in like phase 1, am I right?
Yes, and in the phase 2, the transform set has to match. The transform set will have the encryption algorithm and also the AH authentication header and also DH group. They also have to match in the phase 2. So whenever you configure the phase 1, you also configure the same parameters in the phase 2, just to keep it regulatory.
Oh, okay, yeah, got it. Thank you.
Okay, what's the next question?
Sir, we have different encryption methods, right? How often in your experience did you come across two routers which were not compatible with each other?
Many times, hundreds of times. That will be a whole night troubleshooting scenario, right? You sit with a vendor, you want to form a tunnel, and you both will be talking each other over the phone, asking which algorithm you configured, which algorithm I configured. It's a conflict. In one night, I think I started at 11 in the night till morning 7 a.m. We are trying to build up the phase 1. So it took that amount of time. So it's a painful process. You asked how often. I would say if I build 3 tunnels, one time I will face the problem. For every 3 times I face one time, always the problem.
Okay, so got it. Then how do you overcome it when they're different? You have to reconfigure everything then?
Yeah, I have to reconfigure everything. Make sure that I ask my peer to send their configuration. Hey, send me the configuration, I'll match it on my side. So always try to make sure that you create a spreadsheet. I think I already have a spreadsheet. Let me show it to you. Hold on. How we do it in the real time? Let me see if I can find it. Hold on. It's called Okay. So if you see this, so this is the IKE V2, the version, right? The planner. This is the peer IP address. For the IKE phase 1, we see encryption algorithm, hashing algorithm, DH group. Hashing algorithm is nothing but the authentication header, right? And then the DH group, the lifetime, how much time the tunnel should be active. Similarly, for the phase 2, inside the transform set, the encapsulation, encryption, DI, again, it's called as the authentication header again, the lifetime. The PFS is nothing but the DH group again, the group 20. And this is the ACL that I'm talking about, where we allow the IP addresses of the end users, where we should be allowing over the tunnel. So this is the site they will send to us. It has to match on both sides. By this, we will coordinate over the phone or the meeting, and then we build up the tunnel. Okay, that is how we exchange these spreadsheets over the phone or messages. Okay.
Got it. And it should match word to word. Is it, sir, all parameters or just a few? What do you look at when you look at that?
Well, you can do mix of combinations, right? But the algorithms have to be spot on. They all have to match. Yes.
Okay, sir. Thank you, sir.
No problem. That's fine. Okay. Where are we? Yeah, I think we completed that. I think we did more than what I thought. That's good. Anyways, let's move on to the next one. We'll talk about ACLs, access control list. You might have already known now what is an ACL. ACL is nothing but a gatekeeper. When we are blocking or allowing the traffic, when we wanted to stop the users using the data, when we wanted to filter the data, right? Filtering is a good word. When we wanted to filter the data, in those cases, basically we use ACLs. So ACL has two types. One is standard ACL, and the other one is extended ACL. There are other ACLs that are reflexive, that are named ACLs. We are not focusing on them because it's not part of our syllabus. But let's talk about, I think before we configure ACL, let's talk about the types of ACLs first, and then we can go to the configuration, right? Okay, let me share my screen again. Okay, Shanmukha, we'll talk about that after the class, please. Thank you. Again, this is router A, and this is router B. And this router A has traffic like PCA, PCB. Okay. And this router wants to talk to this router B. But I wanted to block, let's say this is, there are two PCs. Okay. PCC, PCD. Okay. I wanted to allow the PCA to talk to PCC and PCD, but I wanted to block PCB not to talk to PCC or PCD. Okay, so the router interface we can create a condition on the router interface to allow this and to block this, right? So that is the concept of ACL, access control list. Okay. So what is the standard access list? So standard ACL means we are creating that close to the source. Okay. Meaning whenever the PCA is sending the data, we are blocking it on the ingress router. But I can also do it on this router interface, right? I can allow the traffic here, but I can block it here. I can block the PCA at this interface. But we are wasting the bandwidth here. By doing this scenario, if I block the PCA here, the traffic that is going out of router, it is going all the way and getting blocked here. Right? So that's why it is in this case, in this scenario, it is good to use the standard ACL, which is close to the source. Okay. But the standard ACL works at the IP level, IP address level. Meaning, I have to completely block PCA to completely block to talk to PCC or PCD. So it's because it works at the IP level. But what if the PCA wants to talk to PCC for TCP? But what if I wanted to block only UDP? In that case, the standard ACL will not work. Cannot do at the protocol level or the port level. The router with the standard ACL cannot do that. It can do only at the IP address level, and it is good to do at the source level to block complete communication. That is the standard ACL. But the extended ACL can do, it can block at the protocol or port level. Okay. Meaning I can do like, I can allow the traffic of the PCA coming here, and then I can do permit TCP and deny UDP. But at the standard level, I can deny here or allow here, permit IP or deny IP. Okay, so is standard better or extended better? Better, guys.
So what is an example that you would use in real time for standard and extended?
First, I asked a question, right? So please answer my question first.
I feel like
didn't get your question.
extended is better than standard.
Okay, why is that?
Because we can like if we want to block at the like router A itself, we can block it rather than wasting the bandwidth.
I'm sorry, I did not catch that. Can you please slowly repeat it?
So I'm telling we can like save the like bandwidth over there.
In which one? Standard one? We can save the bandwidth?
No. In the extended.
How can I save the bandwidth on extended one? So extended ACL is blocking at this interface, right? Close to the router, correct? So if I block it here, how can I save the bandwidth? I mean, I can also do the extended ACL here. Okay, don't get me wrong. I can also do it here. But what is the difference between standard versus extended ACL? What is the major difference?
We can do port level blocking on extended ACL. So for specific ports, I can block it. So for example, if it is a web server, then I will try to block it on port 80 and 443.
Right, that is correct. So you're saying extended ACL is better because I can go do more granular, right? I can go more granular into my blocking. I can define more conditions. Instead of blocking everything, I can block few and I can allow few. Okay. So in that case, extended ACL is better. But let's say in the use case of blocking PCA, to completely block PCC and PCD. In that case, do you think standard is better or extended ACL is better?
Standard should be better because
Standard.
I want to completely block it.
Yeah, but I can also achieve that with extended, right? I can also achieve that with extended ACL. I can just block the IP level as well in the extended ACL. So not only this, not only at the protocol port level, extended can also do at IP level, right?
Oh, okay.
So standard is like the base version. It is like an advanced version. So extended is always better. Just think about like standard is like the first version. It got more advanced into the extended ACL. Extended ACL. Right?
Okay.
It got more advanced into it. So extended is always better to use it. Based on your condition, you will use it. But some users will still use the standard because it will be less resource usage, because router does not look into the ports. It will automatically look into the IP and it will automatically block it. If you want to block completely, deny without looking into the port level or without looking into the more resources, you will just use a standard ACL because it is less resource usage. It automatically denies it. Extended is more advanced. It needs more CPU to activate that or to read that. That's why extended is a little bit more resource usageful. In that only case, standard ACLs are used. Otherwise, in many cases only nowadays users are using extended ACL. Okay, so Anurag, you asked a question about what is the real-time use case, right?
Yeah.
Let's say this is PC, this is switch, this is router. Okay, and this is connected to internet. Okay. Someone is coming from the internet, coming to my router and trying to access my PC. Okay. Here in this case, I can put an ACL here, or I can put an ACL here and I can block them. Okay. If I'm using like FTP server on the PC, I can completely block FTP here. If I'm using a web server, I can allow HTTP here because they can access my web server, but they cannot access my FTP server. I can block them. So those kind of use cases we can use it. That is just one use case, but any block or allow, usually what they do, they put a firewall here and they'll do the blocking part without doing the ACL. Anyone know the difference between ACL versus firewall? Yeah, I think that's a CCNP concept, but let's discuss that. Okay. There's a concept called session table. I think today we are going out of that's fine. Okay, so let's talk a real-time example. So there is a person, and let's say he is going to a movie theater. Okay, so there is a movie theater. Okay, and there is a gatekeeper. okay, or the ticket collector, or whatever you can call him. Okay, there is a TC here. So when this guy entered inside, he has to show his ticket to the movie operator, the ticket collector, and he can enter into the theater. So here this guy is called ACL, right? But what if this person wants to go out and then comes back up in the same time? The ACL will not recognize the person that he is the same person going out and coming back. The ACL will not have any memory that, okay, this person has the ticket. So next time when he comes back again, he has to show the ticket again and sends him to the inside. But the firewall will have a concept called session table. It maintains the data of this person. So whenever he goes in and when he's trying to go out and when he's trying to come back, the firewall will look into the database session table and it will automatically allow him without rechecking his ticket or the ACL. So the session table is like a memory database that's sitting on the firewall that is not present on the router. Okay. So now let's talk about this. Before I talk this technically, do you have any questions on this workflow, the real-time workflow?
No, sir. Thank you.
Will there be any like a time frame in the like firewall to check the table, session table?
Yes, there is a time that is called session timeout. That can be decided by the protocol, TCP or UDP. I think you guys are asking good questions, but we are a little bit moving away from what we have to discuss. But yes, that will be having a timeout setting. That is called the ideal timeout. For example, let's say you opened a browser. Okay, on your laptop, you opened a browser. After some time, if you don't do anything on the browser, you will automatically log out. Right? Let's say you opened your Bank of America site. If you don't do anything, it will be aging out because there is no user activity. That is called doing the session timeout on the firewall. That's why you get keeping logged out. They will say, due to inactivity, your session is logged out and please re-enter your password. I think you might have seen on your bank mobiles usually, because they will set the timer very low. Have you guys seen that happening on your phone or your PC? If you don't use, if you move to other tab, it will automatically log you out. You have to enter the password again. Have you guys seen that? Yep.
Yes.
Yeah,
Yes.
that is the same timeout happens on the firewall. So now let's talk about the session table. The session table contains source IP, destination IP, source port, destination port, protocol. So this all will be saved in the session table. This is called 5-tuple rule. 5-tuple rule. In the interview, they will ask you, hey, can you tell me what is 5-tuple? You can say source IP, destination IP, source port, destination port, and protocol. This is maintained in the session table. And also the time, sorry. Time is not the 5-tuple, but it also maintains the time period. At what time the session started and what time the session ended. So when the data comes in on the firewall, let's say this is the person with IP address. It's going to a server with an IP address. It tries to go out. The firewall will look at, okay, this person has a source IP 10.10.10.1. It's trying to go to 20.20.20.20.20 on the server. He's using the source port random port and he's using the destination port as 80 on the web server, and web server is using TCP protocol. So he came at 10 in the night. So the firewall will maintain session table. When the server is responding back to the person, it will automatically allow the traffic because this traffic is matching the session table. So this guy, let's say he opened a website to study CCNA. The response packet will be sent to him. The data will load to him, right? So the return traffic will be automatically allowed because the session table is matching the traffic. If it's an ACL, we have to permit the data here, and also we have to permit the data from here because firewall, the ACL will not have any session table. The permit have to be in both directions because ACL does not have any session table memory. So if someone asks you, come and asks you, can you tell me what is the difference between the ACL and a firewall? You need to tell session table. Some people might be smart and ask you like, can you tell me why do I need a firewall when I have a router ACL? They'll ask you that. Then you have to tell firewall is more significant in allowing and denying the traffic because it maintains the session table. Okay. So now let's look into the configuration of ACL. Any questions before I show the configuration?
No, sir.
No, sir.
Yes or no? Sorry.
No, sir.
No.
No.
Okay. So what? Okay. Configuring the ACL, right? Let's talk about the standard ACL first. What? Let's standard ACL. So it's IP address based, right? You can do like access list. You can give the number of the ACL. For example, you can do number 1 and then do deny and then do 10.0.0.1. And if you want to allow, you can do access list allow 10.0.0.2. So basic, you put an IP address and you put a permit or allow. I mean deny or allow. I think it is called not allow, it's called permit. So let me show. Okay. So that is how you configure the ACL. And you apply this ACL to the interface. You will apply this ACL, for example, you will apply this ACL to the interface. For example, interface gig 0/1 access list. I think it is called access group, IP access group. And then you will define the number. For example, you can do group number 1, and then you can do like in or out. If I'm doing inbound direction, I will put it in here. If I'm doing outbound, I'll put it out here. For example, let's say this is the router, and you wanted to the packet. I mean, the person is here, and he want to talk to the server. In this case, the person traffic is coming in the inbound direction of the router. So you can put this as in direction. So we are blocking the person here. This person we are blocking here. If I wanted to block the person on here, what I can do is, let's say this is 0/1, this is 0/2. I can do interface gig 0/2 IP access group 1 out. So what I'm doing here, I'm allowing the traffic here, but I'm dropping here by sending it out. This is not a good idea. It's always good to block the traffic incoming so that it doesn't router does not need to process that packet. Here we are allowing the traffic here, processing the packet and sending it out and then blocking it here, which is not a good idea. Why do we need to waste the router resources? So it's good to block it here. Okay, so it's always good to block in the inbound direction of the router so that we don't have to waste the resources. I think I forgot to mention a point. There is a range for these numbers. I think the range numbers are ACL access list can have 1 to 199. You can use any of those numbers. Just like I used the one number 2 here, right? You can use these numbers for standard ACL. Oh, it's 99. Okay. You can use any number. It's just an reserved number, standard ACL. And then you can also do 1300 to 1999. That is also standard ACL. You can use any of those numbers. If you put 1 here, the router will know, okay, this guy is trying to do a standard ACL. If you put 99, okay, standard ACL. But what if you put 100? That will be extended ACL. So let's look at the ACL 100 to 199 and 2000 to 2699. Okay, that is external ACL. Now let's look at the example of external ACL configuration. Okay. Okay. Let's say this person wants to talk to this server, but I wanted to permit HTTP, but I wanted to block HTTPS. Permit HTTP, block HTTPS. Block it. Okay. The source IP is 10.0.0.1 and the destination IP is 20.0.0.1. Okay. So I'm in the router ACL. Now I'm going to do ACL. So ACL, let's say 199, permit TCP, because this HTTP works on the TCP protocol, right? So permit TCP. Now put the source IP 10.0.0.1 and then the destination IP 20.0.0.1 and then the destination port. The port number of the destination will be, HTTP port will be 80. Okay. Similarly, if I want to block access list 199, deny TCP 10.0.0.1, 20.0.0.1, and 443 port for HTTPS. And I can apply that to the router inbound direction of this direction. I can automatically block it by applying that 199 to this interface. Same here. Interface gig 0/1 IP access group 199. That way I am allowing HTTP traffic, but I am blocking the HTTPS traffic because I put deny statement on the 443, permit statement on 80. Okay, so that's the concept of standard ACL, external ACL, how we can configure it. Okay, any questions? So let's do a quick round. We discussed today about, I think we discussed about configuring IPsec and how do we do the phase 1, phase 2, what parameters have to match on the phases. So Monica, can you tell me what is a Diffie-Hellman group is?
Sir, can you repeat the question, please?
What is Diffie-Hellman group?
Like it's used to protect the password.
Okay, how it will protect the password?
When both parameters will exchange IP address.
Anurag, can you explain?
Sure, sir. I'll give it a shot. So Diffie element group is a parameter that is used for key exchange protocol.
Can you elaborate?
Yeah. So when we are configuring the devices, we use Diffie element for key exchange to make sure that we have stronger security. It is basically a cryptographic standard that we have.
Okay. Well, any other person can explain it in a different way.
Like entering the correct inputs to get the right outputs.
Yeah, it's like an algorithm where we enter the
Yeah.
correct input that will give us the correct output. So if that algorithm is not matching, that output will be deferred. So DH is nothing but an algorithm where you enter some input, you make it through a machine with an algorithm, and you get a right output. That output has to match on both sides. Correct. Okay. Thank you. Okay. Dilip, can you tell me what is a encryption domain is?
You s- Hello.
Yeah, Dilip, go ahead.
Yeah, just come again, sir. What you asked?
I'm asking what is an encryption domain?
Matching on a specific specific thing, like related to the algorithm.
Okay, anyone can try. What is encryption domain? So encryption domain is nothing but the actual interesting traffic that can be flown over the tunnel. It is used in the phase 2. When I apply an ACL, that I'm saying that, okay, this traffic can go over the tunnel or this traffic cannot. So encryption domain is nothing but sending the interesting traffic over the tunnel. That is called encryption domain. It is used in the phase 2. I think you got confused with what is encryption. Encryption is nothing but we are altering the data that it is not in the human readable format. That is encryption. That is, you are putting a key to it. But encryption domain means we are deciding which traffic to go over the tunnel and which traffic not to go over the tunnel. That is encryption domain. Okay, that's fine. I know this is a little technical. You have to go through the recording maybe once or twice to get gist out of it. It's okay, that's fine.
Okay,
Okay, Hari, can you tell me what is crypto map?
Combining P1, P2.
Yes, crypto map is combining all the parameters and applying that map to the interface. That is a crypto map. So whatever in parameters that we configured, we bundle them into one map and we apply that to the interface. That is a crypto map. That is correct. Okay, Kanishk, can you tell me what is a authentication header? Anyone want to try? What is authentication header?
Like,
It's nothing but
it's a
the extra
gangster.
protection for the password, like wherein the key should match on both the routers.
Yeah, it's like a
The
header value that is
extension.
defined to the password, so that header value has to match. Then using that header value, we can read what's inside the payload with encryption, right? So it's basically a code word that is added to your encryption header. That is it is also generated by using an algorithm. It's called a SHA algorithm. We did not go into that details much, but it is also using an algorithm to generate that random key. In our example, I just used a word called red, but in the real time, it also is a random key generator for it. Okay. Well, that is correct. Okay. Okay. Ranga, can you tell me what is a standard ACL?
Standard ACL, sir?
Yes, standard ACL.
Yeah, it is. Sorry, I'm outside. I'm getting some disturbance. So it is like it is used to allow and deny the access to the interface.
But why it is different than extended ACL then? If it is just blocking or denying, how it is different to extended ACL?
So extended ACL can be in extended ACL example, we can if we want to block if we want to use only HTTP, we can use HTTP blocking and HTTPS. I don't think we can do that in standard. We can do that only in extended.
Yes. So if we do at the IP level, and if you are doing close to the source, yeah, that can be a standard ACL. In extended ACL, it's like a next version where we can go into the protocol level and we can block at the port level, right?
Yes.
So that is a difference, correct? Okay. Okay, Shiva, can you tell me what is a session table is?
A session table stores like data for the source IPs, the destination IPs, the source ports, destination ports, and protocols that needs to match for both the devices.
What needs to be matching? Sorry. Yeah, you are right with the 5 tuple, but
for the devices involved, it needs to store all the IP address and port data for both the devices within the session table.
Why?
So that the communication can, or the data can transfer between both
yeah,
the
the
source and destination.
bidirectional communication happen without any policy. Yes. So the both can talk. The reverse traffic can be automatically allowed without having an ACL again, because it maintains the session table.
Mhm.
Correct. Okay. Sudhir, can you tell me what is the functionality of the extended ACL?
Functionality.
Yeah, what is extended ACL? Why it is used?
It uses in the port level, like to block or allow the data.
Okay, is standard better or extended better?
Extended better.
Why?
Because to block at the port level, like as I gave the example of HTTP at the port 80, and we can block the HTTPS.
Do you think any use case where the standard is better?
Standard is better, like it is close to the source. Even extended is close to the source.
No, I'm asking, do you think any use case that where the standard ACL can be better?
Yeah, I think yes.
And what is that use case?
Yeah. Without looking into the port level.
Yeah, I think when we wanted to restrict the number of resources being used to reduce the load on the router without looking into the port level, we can automatically block at the IP level. In that only use case, the standard is better. But usually, if we wanted to have a granular control more, we have to go with extended ACL. Okay. All right, guys, I think we are already past our time. If you have any questions, you can shoot, or I think we are free to talk. Let me stop share. And let me stop the recording.